Hello everyone, very good morning all. I hope everyone is able to hear me. Am I audible? Yeah, that's great. Thanks Raila for the introduction. So I and Divya are going to present both two topics today we have. One is Azure HorizonDB and Divya is going to cover AI and developer workflows overall. So let me start. So my introduction, I am the product manager in Microsoft, working on specifically on migrations, heterogeneous migrations, homogeneous migrations overall. And earlier I used to work in Oracle as a product manager in OCI data integration. So it has been 5 years I have been in Microsoft working on various products in Azure. So before I start with the topic of Azure HorizonDB, let me quickly give the context of Azure Database for Postgres Flexible Server. As you all know, it has been 5 years since it is GA'd. It is a managed PaaS Postgres Flexible Server where it is built on top of, the ecosystem is built on top of open source PostgreSQL, plus it has got extensions overall. And it is a managed service since it is a PaaS service, and overall it gives all the enterprise features what you have. So here comes Azure HorizonDB supercharged on Azure with Postgres. So right now Azure HorizonDB is gated preview. It has been announced during Ignite, that is during November 25 time frame, and it is gated preview, and it is built for businesses where it provides all the enterprise level security, that is Entra ID authentication, you have networking, private endpoint networking, you have high availability disaster recovery, everything, all enterprise features available for, which is built for business. And then it is also engineered for developers, where it is also embedded with VS Code extension, PostgreSQL extension. It is also having diskNN, which is indexing feature, vector indexing feature, and you have mirroring to Fabric as well. So it is also engineered for developers. So let's go into why Azure HorizonDB. So it by default it is Postgres compatible. You can do all the PostgreSQL activities, that is PG dump, PG restore, whatever PG activities you ideally do, you can do it. On top of that, we provide availability. It is zone resilient. So overall, it is available always. It is performant. You will see in the subsequent slides, it is highly performant. It is the write and read latency is in sub milliseconds overall. Then you have scalability. It can go up to 192 vCores overall. So you can scale up till 192 vCores. You have security, like I said, you have Entra ID feature, you have private networking, you have encryption at rest. So everything is available in Azure HorizonDB, and it is dev and AI ready. So it is getting connected to Visual Studio Code, and it is developer friendly overall. So this is the overall why Azure HorizonDB. Then we will go high level overview. So at the bottom you can see it is zoned, it has got zone resilient wall storage, and it has got zone resilient data storage. So here the storage and compute both are different, is separate altogether. So both the storage is zone resilient overall, and the compute is entirely stateless, and it has got 15 HA read replicas, and you have read write endpoint to the primary, and it has the maximum node size of 192 vCores, and the write latency is around sub milliseconds like we discussed, and the maximum storage what we offer is 128 terabytes overall, and we can have 15 read replicas. It is 3x faster than your normal PostgreSQL hosted on premises for OLTP and vector search. So let's deep dive into further into Azure HorizonDB architecture overall. So at the bottom you can see that is a durable storage, that is Azure Blob Storage we have. You are able to see that. And on top you have wall storage fleet, which has multiple nodes. Again it is zone resilient like we discussed. It has data storage fleet, again where the actual data is stored, and you have different nodes overall, and it is also zone resilient, the data storage fleet. you have reader write endpoint where your primary is writing to wall storage fleet, and the wall storage fleet contains the tail of the transaction logs overall, and it gets the data gets the wall transaction gets archived to the Azure blob storage asynchronously. Then the wall storage fleet also moves the data, the transaction data, to the data storage fleet. We will see subsequent slides how the data storage fleet actually works. Then in Azure HorizonDB, the full page writes is off. There is no worry of tone pages, etc., and no checkpointing. So it is directly writing to the wall storage fleet, which is zone resilient, and you need not worry about the checkpoint. Then you have 15 read replicas, and you have a load balancer on top of that, where applications can directly point to that node where it will disperse the data wherever it want to read from replica. And all compute is stateless, and they are enabled with SSD cache by default. So the data is everything is stored in the cache overall. Last but not the least, if the data is like stale, definitely we will also read it from the transaction, the latest data, and we will give the user the latest data always in the transaction mode. So this is the overall deep dive architecture of Azure HorizonDB overall. So let us take a look at a demo first, and then we can understand. So here we are provisioning Azure HorizonDB. Overall, we are giving the cluster name, we are configuring the vcores, and we already have the replicas in zone redundant, that is in different availability zones, and you have how many replicas you require. Then you go ahead and provide the primary availability zone, and you provide the username and password. And you can access the networking like private networking, like you can create the private endpoints, or you can go with the public access, and that's it. You have provisioned Azure HorizonDB in the Azure portal overall. And this is just we wanted to show the demo for the compute read scale. So if you see on the left hand side, we have primary endpoint read write. On the right hand side also we have primary endpoint read write. We have only one replica over here, and on the right hand side you can see 3 replicas overall in the picture. So now we will see how the reads are going to take place. So we are using PG bench, and like we allocated, right? On the left hand side we have 1 read replica, 8 vcores, 32 clients, and the same 3 replicas but 96 clients, and the transactions being processed is 90k, around 200k, and you can see the latency overall is very similar, the read latency. So the number of reads is more here on the right hand side rather in the left, but the latency is overall same. So it is scalable, the read is completely scalable. So under the hood, let's understand Azure HorizonDB under the hood. So we have, this is the large database project which we have built completely on Rust overall, and the disk ANN extension, which is also within Azure HorizonDB, it is also built on Rust completely. So this is the largest. Why Rust? We all know it is memory, it has got memory safety and reliability concurrency overall. So that is where we are using Rust, and it is overall we have created that storage layer in Rust, that is wall storage fleet and the page storage fleet, both are on Rust prepared. So let's understand about the write functionality. So if you see when in a normal Postgres on-prem Postgres server, when you write onto the primary, it goes to the local disk, the data, then it goes to the standby where it sends the data, and again it will write to the local disk, and then it acknowledges that hey, my commit is done. And if it is in different zone, the standby, then the latency is more because it has to acknowledge that on that basis. So overall there are 4 hops over here. Now let's take an example, let's take a look at Azure HorizonDB. So your primary is writing to your wall storage fleet, and you have a major quorum, like out of 3 zones. if you have two zones, the transaction has been written already, it will directly acknowledge, and there is only one network hop overall compared to 4 hops with your on-prem PostgreSQL. So that is the difference between the Azure HorizonDB and Postgres with high availability in the on-prem. So what is this wall storage? So we, in the wall storage, we have each node, and each node has a local NVMe SSD pass through. So what we are using IO Uring. IO Uring is nothing but Linux IO asynchronous calls, what it takes, and we have written a Rust async runtime on top of it, which is, we call it as Kimigeo, and you can access it. That is the link. You can go over it and read about much more about Kimigeo, which is on top of IO Uring, and it has got again the local NVMe, the local SSD, and the whatever the transaction data, it gets archived to Azure Blob Storage overall. So it has got low and predictable write latency overall with this architecture. So what is the life cycle of a write? Let's take an example. So your primary writes to wall storage fleet. Wall storage acknowledges based on the quorum 2 zones out of 3. It has written it down. It will acknowledge to the primary. Then the wall storage fleet sends the data to data storage fleet, where it we have a concept called wall filtering, where it ensures that if the shard is not having the complete picture or complete data, like for example page 42 is not available for one shard or one node, then the wall storage fleet only will send the page 42 overall to that shard or to that node. So it will not send the entire page to what you call data storage fleet overall. So that's where we are also saving lot of network IOPS over here. So that is the concept, and definitely read replicas will read from the data storage fleet to get the actual data and present it to the users. So just a demo again on cross zone write latency overall. So on the left you can see we have a Patroni cluster where you have a primary and you have sync standby, and on the right we have you will have a HorizonDB cluster overall, which is 17.5 version, and now we will try to write the data overall. You can see on top this is like it is in the VM running and it is in HorizonDB running, and you can see we are writing around 9k transactions per second, whereas here we are writing around roughly 4k transactions per second, and you can see the latency, the commit latency over here is very less. It's in sub milliseconds overall what we were discussing compared to the on-prem Patroni. This one. Again, these are not these are just the numbers. It is not the actual, but we have tested it out. So now let's talk about PostgreSQL failover quickly. So what happens in the PostgreSQL failover is when your primary is down some other reason, so the the standby gets promoted to primary, right, and all your writes stop in the primary and goes into that the actual standby, right. So what happens here is when again when I want to spin up that second server, I need to do a PG rewind over there, which will take a lot of time depending on the data size, and there are other techniques as well, but it will take time to just again make it readable standby overall based on many factors, right. But in PostgreSQL, since as you can see on the top, VMs are stateless, so your primary is down some or the other reason, all the writes get stopped again, and your readable standby will switch role to the primary, and you can bring back the main primary VM and reconfigure that replica. The wall storage fleet is as same as that. It will directly point out to the wall storage fleet, and you can directly go over and just start reading that data from there. So it is again the failover time over here is based on the earlier slides, it was 5 milliseconds overall. So let's understand the life cycle of a read over here in Azure HorizonDB. So what happens in PostgreSQL is when you start reading the data, first it goes in the shared buffer. It will check whether the data is present or not in the shared buffer. If not, it will go into the local SSD cache, where it will check again whether the data is present or not. If it is not, then it will go and directly execute a function called getPage@lsn, where it will go and directly take the data from data storage fleet, and it will give the data to the user accordingly. And of course, wall storage fleet contains the tail transaction logs. So if there is some mismatch, definitely it will also have the data from wall storage fleet over there. So let's understand more about data storage. So we have segments, a lot of segments, right? So here in Azure HorizonDB, all the segments get split into blobs, and those blobs are like again they are zone resilient overall, and you can see if one page server is full, then it will like it has got lot of blobs, then it will try to split into different nodes overall, and it will ensure that it is zone resilient, and it is you can access the page data very fast from this. So this and you have all the segment data into each shard, and Postgres can request pages from any shard to lower tail latencies overall. So yeah, please. That is the compute where we have shown the stateless compute, where it will just pick the data from the data set. No, compute does not manage the storage. It is managed separately. The storage layer is completely different altogether. Yeah.
So when you say Postgrescompatible, it's completely Postgres database engine only.
Yes.
Compute and storage is what decoupled.
Decoupled. That is our architecture. Yes, that is.
With SSDs and
That is.
other optimization.
That is correct. Yeah.
Okay. And writes are still scalable only vertically in this architecture, right? Still limited to one node only. Right?
Not necessary. I can get back to you on that as of now, but it is not limited to one compute. I can confirm on that definitely. Maybe Claire, we can take the email ID or something. Yeah. Okay. I just want to let you know about this slide. This is a very interesting slide. So all these processes what we run on PostgreSQL, these are all processes we have saved overall. So everything is handled by the storage layer behind the scenes. So nothing is at the compute layer. All these processes went to the storage layer. So everything is handled by the Azure HorizonDB storage layer overall. So that is what this slide says about. Okay, thank you. Thanks a lot. This is overall picture of Azure HorizonDB. Any questions, do let me know. I am here itself, and I will hand it over to Divya, my colleague.
Kind of likely price difference between the HorizonDB and the equivalent
Price difference? Right now it is in gated preview, so right now we have not revealed the price as of now. Yeah.
So in HorizonDB we are using shared storage for wall fleet
Shared storage means?
Shared storage means we store the entire wall files in wall fleet. It is accessed by the primary as well as replicas.
Yes, yes, that is correct. That is correct. For one particular Horizon cluster only, HorizonDB cluster.
So if we use multi-zone, so each zone we have to separate storage to store the wall files.
It is again internal architecture where the data is replicated kind of in different zones to ensure that it is highly available, kind of within that wall storage fleet and within the data storage fleet.
Wall storage will be replicated, and that higher storage.
There is means when I say replicated, it is like copied over different zones. I would say within the wall storage fleets itself. So that's why it is called zone resilient overall. Yeah.
Can you talk about disaster recovery? Do you manage disaster recovery, or do I need to take care of it?
The recovery.
Disaster recovery.
Disaster recovery is inbuilt. It is in.
Inbuilt.
Yeah.
So I can choose a secondary zone or secondary region, or
Yeah.
or do I need to specify a region of my choice?
No. You can choose the secondary region, and you can. That's where the enterprise feature of disaster recovery is there already. You can have replica in different what you call region.
And
You can have.
let's say for backup, can I have policy of nightly backup versus on-demand backup?
That I think it should have overall, but definitely I am noted down this point. We can definitely reveal it. Definitely, it is there. Definitely, it is an enterprise PaaS service. It will be having the backup service for sure. But what is the maintenance window or what is the backup window? I don't know right now.
Normal flex servers, we do backups at nightly.
Nightly.
Okay.
So
I think similar kind of thing has
This
this.
point
Yeah.
it will be similar,
Yeah, it will
but
be
yeah, we
Yeah.
might make some
May-
changes.
for operational purpose, right? I might want to do an on-demand backup.
right. Yeah.
yeah, you can do that. That in flexible server we do support. The same way you can do support in Azure HorizonDB as well. Yeah. Okay.
In Horizon, can we use multi-master?
That was the question same asked. I need to figure it. I need to find it out. Yeah. As of now, I don't have the answer. Yeah.
I don't think we have revealed any multi-master at this point. At
Yeah.
least, yeah.
Multi-master, multi-master. That's what we are at.
Yeah.
One master, multiple.
One
Yeah,
master,
multi-
yeah, is what it is at this point. Yeah.
Okay. Thank you all. Thanks. I will give it to